Starting off with part A, the question is asking us to find the slope of the line tangent to the graph of f at x equals pi. Because it's asking us for slope, we're likely going to have to find the derivative of the original function. And then to solve, we're going to just plug in pi to the x of the derivative. The equation should look something like this. And the only rule we need to get here is the chain rule. First, we find the derivative of cosine, which is negative sine, and 2x. Then we find the derivative of 2x, which is just 2. The derivative of anything of e to the power is just e to the power. And then the derivative of sine is cosine, so we bring that out here. But let's not forget that we need to move this to the front of this in order to make this whole equation worth 1 point. Next, we just rewrite our equation, but plugging pi in for x this time. Now we just solve the equation, and we should know by analyzing any sine graph, or negative sine graph, that it being at 2 pi, which is right here, is going to be 0, so we can already write that 0. And then to find the solution of e to the sine of pi, we just need to look at sine of pi in the first place, which this time is going to be like this. And just as 2 pi was right here, pi is going to be right here, meaning that's going to be 0. And anything to the power of 0 is just going to equal 1 flat out, so we can already have that. And to finish off, we're just going to find cosine of pi, which by analyzing the graph is going to be about negative 1 at pi. So we can just multiply 1 by negative 1. By doing some easy maths, we should come to the solution that f prime of pi is going to be equal to negative 1. And that's going to be your final solution. And you're going to get your points based off of your first equation, finding the derivative, and then your combined equation of plugging it in and finding the actual answer, which is negative 1. There's only 2 points available for this question, and that's going to be the simplest way to get both of them.
Part B reads, let k be the function defined by k of x equals h of f of x, and it's asking to find k prime of pi. So the first thing we need to do is write down the equation for k prime of x. K prime of x is going to be h prime of f of x times h prime of x, as it is a chain rule and you need to take the derivative of everything. Now plug in pi. If you did part A, you'll see that f prime of pi is negative 1, and then just plug in pi to the equation, you'll see that it's 2, the equation of f of x, not f prime of x, and you'll get left with h prime of 2 times negative 1. To find h prime of 2, you need to see what the slope is on the graph of h at 2, and you'll see that it is negative 1 over 3. Now you have negative 1 over 3 times negative 1, which will give you k prime of pi, which is 1 over 3. And now you've done part B.
So for part C, we're going to be using the product rule, and that's just the derivative of f of x times g of x plus the derivative of g of x times f of x. So then we look at our equation which as you can see here is g negative 2x times h of x, and we use that in the product rule, so we take the derivative of g times h plus g times the derivative of h, as you can see here. So then we plug 2 in for x, and we're left with this equation. And to get the values, we're going to be looking at our table. So as you can see here, we're going to be using g at negative 4, which is negative 1 and 5. And then for our h values, first we're going to look at h2, which is negative 2/3, and then we're going to take the slope of the line to get the derivative at h of 2, and for that we're going to get negative 1/3. So you're going to plug those values into your equation, and then you're just going to do some mathematicals, and your answer should be -3.
Alright, so for part D of FRQ number 6, the question is asking, is there a number C in the closed interval -5, -3 such that g prime of C is equal to -4? Justify your answer. So immediately you should be thinking MVT. And the interval that they provide is -5, -3. And we are working with g prime of x. So we'll be looking at this graph up here. But the only portion of this graph we're worried about is right here, that interval -5, -3. So before we can perform the MVT, we must find that the function is differentiable and therefore continuous on the closed interval provided. Um, and lucky for us in this problem, they already let us know that g is a differentiable function. So we already know that g is differentiable and therefore continuous. And so now that we've gotten that out of the way, now we get to find out if there is a number c in the closed interval of 3 such that g prime of c is equal to -4. So by the MVT, we know that g prime of c will equal g of -3 minus g of -5 over -3 minus a -5. So now that we know, we have a sort of outline. Now we just need to start plugging these values into our equation. So first of all, I'm going to clear some of this up so it doesn't look. Well, that's not what I meant to do. Clear some of this up. Okay. So now we have g prime of c is equal to f of -3, which is 2, minus f of -5, which is 10, over -3 minus a -5. And that there is going to give us -8 on top and 2 on bottom, which is going to equal -4, which is what we were looking for. Now moving forward, you're going to want to keep your work here because that's going to get you a point on this problem. And but for me, for the sake of room and the fact that I have none, I'm just going to get it out of here. And now we need to justify our answer in words. And in order to do that, I am going to insert a text box because my handwriting is not good enough to do it without one. And so now we're looking at our text box, or my text box, your paper. And so I mean, you're going to have what you had before still on your paper, and you're going to write, therefore, by the mean value theorem, there is at least one value C on the interval -5 is less than C is less than -3, such that G prime of C is equal to -4. Now that you have this written out, that will be another point. You get a point for the work to find -4, and then you get a point for the justification using the mean value theorem. And in this instance, I purposely left out something you need in your justification to earn that point, and that would be the statement that g is differentiable and therefore continuous on the interval -5, -3. So that must be stated in your justification along with your work and the statement that I have in the text box right here, and that should get you your 2 points. Um, now that we have that, we need to focus on some other things you might do that could cost you those 2 points. Um, of course, one of which is bad math. Always, you can always mess up on your arithmetic or your algebra, which in this case I hope not, but you may. Um, and another, just fundamental, you might look at the wrong graph. Make sure you're focusing on the problem and what it's asking. Make sure you're looking at the variable, especially when there's multiple variables like this problem graph of h, table of g of x, and then a function of f of x, so you get the right values. And one other thing that you can mess up on is some people fail to justify their answer completely. They don't go by the MBT, which can cost you a point. Um, and that's about it for FRQ number 6, part D.